Welcome to your IELTS listening practice from Spinta.org. This is a mini test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Good afternoon, everyone. Today we are going to explore a fascinating topic in structural biology, which is enzyme catalysis mechanisms. This area touches on one of the most fundamental processes of life, essentially how enzymes work to speed up biochemical reactions in our bodies and the environment. Enzymes are biological catalysts that significantly accelerate the rates of chemical reactions in living organisms. Without them, many of the reactions necessary for life would occur far too slowly to sustain biological processes. The heart of enzyme function lies in its structure, particularly the active site. First, let us define what we mean by active sites. An active site is a specific region on an enzyme where substrate molecules bind and undergo a chemical reaction. The shape and chemical environment of the active site are crucial for the enzyme's function. Furthermore, the concept of an active site relates closely to the lock and key model, which proposes that the enzyme's active site is precisely shaped to fit its specific substrate, much like a key fits into a lock. Alternatively, the induced fit model suggests that the active site can change shape upon substrate binding, allowing for a more effective interaction. In addition to physical shape, the chemical properties of the active site play a significant role in catalysis. The active site contains amino acid residues that help stabilize the transition state of the reaction. This stabilization lowers the activation energy required for the reaction to proceed, ultimately accelerating the reaction rate. To illustrate how these concepts are applied, let's consider the enzyme lysozyme, which helps in breaking down bacterial cell walls. The active site of lysozyme comprises two key amino acids that form a cleft for the substrate, leading to the formation of a transition state that is significantly more favorable than that of the uncatalyzed reaction. As we delve deeper into the mechanisms of enzyme catalysis, it is crucial to mention the role of cofactors and coenzymes. Many enzymes require additional non-protein molecules that assist in their catalytic activity. For instance, metal ions such as zinc can act as cofactors in the active site to facilitate the reaction process. Let's also talk about how enzymes exhibit specificity in their response to substrates. This specificity is largely attributed to the unique arrangement of the amino acids in the enzyme's active site. Enzymes like pepsin, for example, show specificity for peptide bonds, facilitated by specific interactions within its active site. Moreover, enzyme kinetics significantly sheds light on how an enzyme's structure influences its function. According to the Michaelis-Menten model, the rate of enzymatic reaction is dependent on substrate concentration, and it demonstrates how the initial reaction rate increases up to a maximum velocity as substrate saturation occurs. We must also consider enzyme inhibition, which can provide insight into the mechanism of enzyme action. Inhibitors can bind to the active site or affect the enzyme's conformation, thus reducing its activity. This type of regulatory mechanism is crucial for understanding cellular metabolism. In conclusion, enzyme catalysis mechanisms encompass a diverse range of concepts from the structure of active sites to the kinetic properties of enzymes. By understanding how these biological catalysts work, we gain insights into not only basic biology but also therapeutic approaches to diseases associated with enzyme dysfunction. Thus, enzymes accelerate reactions by providing a specific active site, stabilizing transition states, and lowering activation energy. By studying enzymes like lysozyme, we can ascertain how the active site and catalytic efficiency correlate with result there. Thank you for your attention. I hope this overview has provided you with clarity regarding the fundamental mechanisms of enzyme catalysis and their significance in structural biology.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.